Alrighty, so this is lesson 1-6. We are talking about relations today. And if this voice maybe sounds a little deep and unfamiliar, it's not Miss Buddha, Miss Coffee with a bad cold or anything like that. It's just Mr. Faust. So just want to set you straight there so you weren't too worried about them or anything. Alright, so a coordinate system is formed by the intersection of two number lines, the horizontal axis and the vertical axis. So let's talk about those. I'm going to start here in the bottom right. The horizontal axis is also called the x-axis. You might have known that. That should sound pretty familiar. So that runs left to right across our graph there. Now I'm going to go top left. The vertical axis is also called the, you could probably guess it at this point, y-axis. Right, x-axis, y-axis, that forms your graph. That should sound kind of familiar. Let's go bottom left here. The blank at 0, 0 is the point where the axes intersect. So it's right in the middle of your graph. Might be another one that you're familiar with. It's called the origin. Right, so right in the middle of your graph there, where your lines intersect with a big O, that means origin. The plane containing the x and y axes is the coordinate plane. So that's the whole picture you're seeing. You might, you'd probably just say the graph, right? Just the empty graph is called the coordinate plane. And then each point is named by an ordered pair. So like the one they have on here, 2, 3, we call that an ordered pair. Okay? Just a way to plot a point there or look at a point. Okay. Set of ordered pairs is called a relation. A relation can be represented in several different ways, as an equation, in a graph, with a table, or with a mapping. So we have 4 different ways, and then you're going to write those 4 ways on the front cover of your notes. A mapping illustrates how each element of the domain is paired with an element in the range. So we are looking at a mapping right there. The set of first numbers of the ordered pairs is the domain, and the set of second numbers of the ordered pairs is the range of the relation. This mapping represents the ordered pairs, and then they're listed there for you. So first things first, I just want to make a note here, and that is that the domain is talking about your x values, and your range is talking about your y values. So a lot of times we're going to talk about x values, y values. We'll probably do that more than referring to them as the first numbers in the ordered pairs and stuff like that. So I just want to get that note down for you. And then what we're going to do is we're going to list our domain and range. So if I look at that set of ordered pairs, I'm going to use that to fill in our domain and range. As a matter of fact, let's actually look at the mapping. So let's compare the mapping to these ordered pairs. So for example, if I look at this first ordered pair, -2, 4. -2 is an x value, 4 is a y value. If I then look at the mapping, I see a -2, and then I see an arrow coming from it that goes over to 4. That's the relationship there. -2, 4. If I see it here as a point in an ordered pair, I'm going to see it looking like that on the mapping. -2 with an arrow going over to 4. All right? So let's maybe try to use our mapping to fill in our domain and range. So for domain, I'm going to just list the numbers I see here, -2, and I'm going to use commas, -1, 0, 1, 2. And then we use this special notation when we're talking about domain and range. It's a symbol that you can find on your keyboard, on your Chromebook. It's called a brace. Looks like this. So we're going to close this out with braces. And then for the range, I just see these 3 numbers, 4, 6, 8. I'm going to write 4, 6, 8. I'm going to put the braces around those as well. Now there's one note here just to pay attention to. It says don't list repeated numbers in domain and range. So what that's talking about is if we go back to our list of ordered pairs, if we're focusing on that instead, I'm seeing, for example, in my range, I see 2 4s showing up, and I also see 2 8s. So all that's telling us, this note down here again, it's telling us when we're using a set of ordered pairs like that to write our domain and range, and we see a number show up twice, we're still only going to write it once when we're listing out our range or our domain, wherever the number might show up twice. So something to keep in mind. With the mapping, we didn't have to worry about it, right? Just showed up there 3 times anyway, so that was nice and easy. So just a quick note there to keep in mind about. All right, moving right along. So now we're going to look at some other ones. So first we're looking at just these ordered pairs, right? We've already looked at those. You've seen those before. Then you have a table. Here's your table. That should look pretty familiar to you. You've definitely seen a table before. And it's easy to see the relationship between the ordered pairs and the table. Here's 1, 2. Here's 1, 2. X comma Y, and it shows up in the X column and Y column. The graph is just us plotting those points. So for example, again, 1, 2, I'm going to graph it. I start at the origin. That's telling me to go right 1, up 2. That's how I get to 1, 2 on the graph. So that's just plotting all the points. And then the mapping we already talked about. So we should be feeling pretty good about that. So now on the bottom half of the screen, we're going to fill these in ourselves. So here is our set of ordered pairs. That's our relation. And we want to make it look like a table, a graph, and a mapping. So again, the table should be pretty easy. That first point, 2, 5, that's just going to look like a 2 and a 5 in the X and Y column respectively. Now I'm going to just go right on down. -1, 3, 5, -2, and -1, -2. Again, I'm just taking the points from our set of ordered pairs. So -1, 3 is on the table as -1, 3. That's how they all get filled in there. The graph, again, hopefully you remember how to graph. So 2, 5 is telling me to go right 2, up 5. I'm just going to label this as 2, 5. Then I have -1, 3, left 1, up 3. -1, 3. Then I have 5, -2, right 5, down 2. And then last but not least, I got -1, -2. So there's our points all plotted. So our graph is filled in. And then for our mapping, again, hopefully we're starting to feel pretty good about a mapping. I'm going to write my domain values in my domain column. So I see 2, -1, 5, -1. So, and that sticks out to me because I've seen that -1 twice, but again, I'm only going to write it once. So I have 2, -1, 5 in my domain column. I like that font. I'm going to fix it. There we go, much better. Okay, and in my range column, see which color I want here. That makes a big difference. I see 5, 3, -2, -2. So again, that's hitting me right away. I see 2 -2s. I got to remind myself to only write it once. So I'm going to do 5, 3, -2. All right, so I got those all filled in, but if you look at the other mappings we took a look at, I need some other stuff on here, and that would be my arrows. So where should I have arrows? Well, the first point was 2, 5, so I need an arrow going from 2 over to 5. Got some yellow boxes staying up there for me. Oh, there it goes, okay. Next up, I got -1, 3, so I'm going to draw an arrow from -1 over to 3 with the arrow and not just a pen. -1 over to 3, there it goes. Then I have 5, -2, so 5 goes over to -2, and -1, -2. So I'm going to go back up to my -1. I'm actually going to have another arrow coming out of that, and it's going to go to the -2 as well. So there's my mapping all filled in. Alrighty. Now we're going to kind of change it up a little bit here. We're going to talk about independent and dependent variables. So usually when these come up in class, we have students saying like, oh, is that like science class? Because that's probably where you most use these or first heard about them. So let's define these first of all. Independent variable is the variable that determines the output. That determines the output. And then I'm going to put in parentheses here, that's x. So that has to do with our x values. And then on the other hand, dependent variable is the variable that is dependent on the independent variable. And then we're going to make another little note up here, parentheses, that's going to be y. That has to do with our y values. All right, so that, obviously that's a little bit wordy. You know, that might be a little hard for you to understand. So we'll look at some examples here, but it's really about cause and effect, right? You might even make another note somewhere about that. The independent variables are your cause, dependent variables are your effect, and it's also what came first. So the independent variable usually happens first when you think about it. Right? So let's look at example A here. The directions tell us to identify the independent and dependent variables for each relation. So A has to do with a dance. The dance committee is selling tickets to the fall ball. The more tickets that they sell, the greater the amount of money they can spend for decorations. So the first thing I need to do is figure out what are the two variables in general, not even which one's independent, which one's dependent, just what are the two things I'm dealing with in this problem. If I look at this again, the dance committee is selling tickets to the fall ball. Okay, that's kind of just setting up the scenario. Then it says the more tickets that they sell, the greater the amount of money they can spend on decorations. So first thing we're dealing with is the tickets that they sell, the amount of tickets that they sell. And then the second thing that we're dealing with is the amount of money they can spend for decorations or on decorations. Right? Those are really the two things we're dealing with. How many tickets do we sell? How much money do we have for decorations? So those are our two variables. Now let's figure out which one's which. So again, in order to do this, I think about which one would happen first. So let's first consider maybe they sell the tickets first. So if they sell the tickets first, they say, let's sell tickets, see how much money we get, see how many people want to come, and then we can spend some money on the decorations because we'll have all that money to spend on the decorations. All right, so that's one possibility. The other possibility is if we flip it and do it the other way around, they go to the store, they don't know how much money they actually have to spend on decorations, but they spend a bunch of money anyway, and then they go ahead and try to sell the tickets and make up all that money they spent. That's a little bit worse, right? That wouldn't make as much sense. So for that reason, seems like they're selling the tickets first. That's our independent variable. So the independent variable we're going to say is the amount of tickets they sell. The amount of tickets they sell, or you might say the number of tickets that they sell, how many tickets, right? Notice we're not just going to say tickets, and the reason is we have to be specific. We're talking about the amount of tickets that they sell, or the number of tickets. We're not talking about the price of the tickets. We're not talking about the color of the tickets or how good they smell or anything like that. We want to know how many tickets. So we got to be specific. The dependent variable then has to be the amount of money they can spend for decorations, and that sounds good. Let's just write that. The amount of money, I'm going to use a dollar sign, they can spend on decorations. Makes sense. All right, 2b. As the amount of rain decreases, so does the water level of the river. So again, first I gotta, I like to underline, what are the two things I'm even dealing with in this problem? So I would say it's the amount of rain and the water level of the river. Those are really the two things I'm looking at. Notice I'm not underlining words like decrease, or in the other one, I didn't underline the words more or greater. I don't want to underline words like that say whether it's going up or down. I just want to know about the general pieces that are making up this problem. So again, let's consider, which happens first? Do we get the rain? Do we get the water level of the river? Well, either it first rains a lot and maybe the amount of the water level of the river goes up, or if it doesn't rain a lot, the water level of the river goes down, or otherwise the water level of the river, if I flip it the other way around, tells me how much it's going to rain. In other words, if I go to the river, take a big bucket and take a bunch of water out of the river, then since the water level of the river is lower, that tells me it's never going to rain. Or if I put a bunch of water in, I'm going to make it rain. Sounds pretty goofy. I'm pretty sure it rains first, and then you figure out how high the river is going to be. So let's just fill in based on that, and this is going to be the amount of rain for our independent variable. That's the one that happens first, and then dependent is going to be the water level of the river. Pretty sure that makes more sense to us. Water level of the river. I have fun with these. I mean, I think they're pretty funny. I'm sure Miss Coffee, if she's watching this video, is laughing. She always gets a kick out of that. So anyway, that's the end of the video. I don't have any big closeout for you here or anything like that. I'm not sure what Miss Booty usually does, but hope you enjoyed it, and I'll see you in the next one.